Okay, now I hope you tried this task again. So this time we are going to try to attempt to prove the 30, 60, 90 triangle. So the first question is, are the triangles congruent? So if you remember earlier in the week, we talked about similarity and proving if triangles are congruent. So here, this original angle is 60, and then each part split into 30. So based on the angle theorem, we can say both triangles are congruent. Cool. So now, what is the length of the shorter leg of each of the triangles? So I'm going to erase this, and I'm going to actually write the 30 degrees in, which is cool. I can just zoom in and write 30, 30. Let's erase whatever that was. Okay, so remember, the shortest leg is always across the smallest angle. So we are talking about from here to here. So remember, the original from here to here is a length of 2, since it's an equilateral triangle. But we want to know what's from here to here, so we know that it's half, and it's going to be 1. And also, we didn't assume that it's half. It told us that the altitude, which is this line in the middle, splits it into 2 triangles. So we know that this is 1. So our shorter leg is 1, and you can say that it's half of the original length. So now we're going to use Pythagorean theorem to find the altitude. So I'm just going to cut out this half of the triangle and look at it like this. We know this is 2, so we're trying to find this side. So we have 1 squared plus b squared equals 2 squared. We'll subtract 1 from both sides, and then take the square root. So the altitude is a length of square root of 3. So now we're going to talk about the ratios. So the ratio from the shorter leg to the hypotenuse. So we remembered that the shorter leg is a side across opposite to 30. So this is 1, and the hypotenuse is 2. So what this means is the hypotenuse is always going to be twice as large as the side across 30 degrees. That's going to be something important to remember later. So now we want the longer leg, which is the one opposite to 60. So that's square root of 3, and the hypotenuse is still the length of 2. And then the ratio side from the shorter leg to the longer is 1 to square root of 3. So all this is saying is whatever you multiply one of the sides by, you're going to have to multiply the other. So let's look at an example. So there's a lot going on in this picture here. There it is, try to show you that the short leg is across 30, the longer leg is across 60, and that this is the hypotenuse. So what I'm actually going to do is I'm just going to draw the same triangle just to the side. I think it'll be a little less confusing. So I'm going to draw it the same way. So 60, 30, and the problem says that the hypotenuse is 16. So there's a lot of ways to approach this problem. So we're going to look at the original triangle. I'm just going to draw this up here again. And It's okay to keep writing it over and over again. It's going to help you memorize it. So remember, it's 1 square root of 3, 2. So what this tells me is 16 is my hypotenuse. So the easiest side to probably look for is the one across 30. Because what we discovered is the one across 30 is always half of the hypotenuse. So since this is 16, that means this has to be 8. And now, going back to the original picture, what do I have to multiply 1 by to get 8? Well, I have to multiply 8. So my scale factor is 8. So I actually multiplied my standard triangle by 8. So that means the side opposite to 60 is going to be 8 square root of 3. So that's just a really important concept to understand, is that we're just multiplying by a scale factor. And if you discover what that scale factor is, it just helps you with the process. And that's pretty much it.